Okay, this is section 4.6. This is solving radical equations and equations with rational exponents. Okay, so when you are solving a radical equation, just like when we solved an absolute value equation, you want to isolate the radical. We did that for solving an absolute value equation where you had to isolate the absolute value. And then we also did that when we were looking at using the square root property. We wanted to isolate our x squared term so that we could take the square root of both sides. So again, here you want to isolate the radical. Okay. And then the next step is you want to raise both sides of the equation to the power of the radical. If it's a square root, then you raise both sides to the second power. If it's a cube root, then you raise both sides to the third power, and so on. And then once you do that, if you have a radical that's still left over, then you start all over again. You isolate that radical, raise both sides to whatever power that is, and then solve your equation. Now, after you solve, you need to check your solutions. They are not solutions, they are potential solutions, and you need to double check those inside the original equation. Okay. Now, the reason why is whenever you raise both sides of the equation to some power to remove that root, you are actually throwing in another solution. And that extra solution that you throw in may or may not work. So that's why you always have to check it. And so they give you two examples, and you can walk through this and you can see how they do that. So on both sides, they've isolated the radical. Then they square both sides. Now, the left equation is a lot simpler. Okay, you get your answer, you plugged it in, they checked it, it worked. So that's your answer, is x equals 12. Now, over here, when they did that, notice how we ended up with a quadratic. Well, the highest exponent is a 1. The exponent here is going to be a 1/2 because it's a radical. Here it's a 1. So the highest exponent is a 1, but whenever you square it, notice how now it gave you a quadratic, which means two solutions. So since it gave you two solutions, you have to check it, because look, in this case, when you check the 0, it does not work. So you have to throw that answer away, but the 8 does work, and that's the one that you keep. So that's why it's very important for you to check both of your solutions. And then we'll get into what I just said about this side having an exponent of 1/2, and this being the 1. We'll get to that in just a minute. Okay. So number 1, we look at this and I notice that my radical is isolated. Perfect. That's what we want. Since it's isolated, this is a square root, so the power of the root is 2. So I'm going to raise both sides to the second power. So on the right side, the square of a square root is just going to knock each other out to just give you the 4x minus 15. Now, it's important that you can multiply this out really quick. And I know a lot of you are going to, well, some of you might make the mistake and say, oh, that's just x squared minus 25. No, it's not. This means x minus 5 times x minus 5. So that means you would have to FOIL. But I want to emphasize a shortcut to you. So let me just, actually, let me do this in a different color. And then let me just kind of make myself a little box here. So you have two squares of a binomial. We have a plus b quantity squared, and then we have a minus b quantity squared. Now, let me show you how to do this real quick. You take the a and square it. Now, my middle term is for these square of the binomials is always a 2ab. So I need a 2 times a 2 times A, and B is positive. So that's a plus 2AB. And then your last term is that you take a B and square it. So that's a plus B squared. So when we do this one, you take the A and square it. Then we have a 2 times A times B, except this time B is negative. And then minus B times minus B is a positive B squared. Okay, so if you notice how they're both the same, so you multiply 2 times A times B, that gets you your middle term. So the front is just A squared. And notice the back. If you square a positive, you get a positive. If you square a negative, you still get a positive. So your last term is always going to be positive. So watch. Here's what we're going to do. So x squared, that's our first term. Now I have a 2 to get the 2ab, 2 times a, 2 times x, times a negative 5. Here's the negative, and then there's the 5. Let me scoot this over. So minus 2 times x times 5 plus the 5 squared. So we have x squared minus 10x plus 25 equals, and then we've got the 4x minus 15. Okay, so I have a quadratic, which means I need to bring everything to one side. So I'm going to subtract 4x, so that gives me a minus 14x, add 15, which is going to give us a 40, that equals 0. Now we're going to factor. Always go for factoring. So what two numbers multiply to 40 that can get you 14? That would be a 4 and a 10. How do I get a negative 14? Well, both of these would have to be negative. So then our two solutions, one is a 4 and one is a 10. So I have to plug these back in and check. And I'm just going to, we're just going to visually do this. So if I plug in a 4, well, 4 minus 5, that's a minus 1. And that already looks fishy. So 4 times 4 is 16. 16 minus 15 is 1. The square root of 1 is 1. Negative 1 does not equal a positive 1. So x equals 4 is not one of my solutions. Okay? So now we need to check the 10. 10 minus 5 is 5. 4 times 10 is 40. 40 minus 15 is 25. The square root of 25 is 5. That one checks. So out of the two solutions that we got, only one of them worked. Okay? And again, that's because when we raised both sides of the equation, we threw in that extra solution, which gave us that quadratic, and we had to check it. Okay? All right, now number 2, I need to isolate the radical. So the first thing that I need to do is to divide both sides by 2. Okay, so we're going to have the cube, that's gone. So we have the cube root of 4x minus 8 equals 2. Now, this is a cube root, and the way that I get rid of a cube root is I'm going to raise both sides to the third power. So the cube of a cube root, those knock each other out to just leave us with 4x minus 8 equals 2 to the third. Well, that's 8. Now we solve. So we add 8 to both sides and get a 16, and x is 4. So we're going to plug this back in. 4 times 4 is 16. 16 minus 8 is 8. The cube root of 8 is 2. And 2 times 2 does equal 4. So this one works. So we're good. Okay. So again, we're checking it. You have to check them. Okay. But we're just checking it by plugging it in and visually doing this. Okay, number 3, I need to isolate the radical. So that means I have to subtract the 6 from both sides, and I end up with the -4. Now, there should be all kinds of bells and whistles going off here, because anytime you take the square root of a number, you will not get a negative answer back. Okay? This can't happen. You cannot take the square root of a number and get a negative number back. So when this happens, stop, and this is going to be a no solution. If you forget and you go ahead and square both sides, please make sure that you check your answer. And when you check your answer, you're going to find out that it just doesn't work. Okay. Now, number 4, I'm going to explain this a little bit different than how I did this in class. And I need to make a note off to the side, because this is part of 4-5, which we didn't cover. But I do need to talk about what is a rational exponent. So a rational exponent looks like this: a to the m over n power. It's when your exponent is a fraction. Okay. Now, this can be rewritten in one of 2 ways. We can rewrite this as the nth root of a all raised to the m power, or the nth root of a to the m. All right. Now, let me show you how this works. If I take 4 raised to the 3/2 power, okay, so match it up. So n is the power of the root. Since the denominator is a 2, that's a square root. So that would be the square root of 4, and then I cube it, or it would be the square root of 4 to the 3rd. Now, which one of these is going to be a little bit more involved to deal with? And it's going to be this one, right? Because here, well, the square root of 4 is just 2. That's raised to the 3rd power, which just gives me 8. Okay. And this one, this is going to be the square root of, well, 4 to the 3rd is 64. Now, that's not a big enough number to deal with. We should know that the square root of 64 is 8. But what happens when your base is a little bit larger? Okay, then that means that if you raise it to that exponent, you get a really big number, and then you have to find the root of that number. Okay, so if you will remember this, I always draw this picture. So if you'll remember this, so this is a tree, and the roots are always at the bottom. So if you'll remember this, then anytime you see a rational exponent, then and if you forget, you're thinking, okay, wait, one of them is the exponent, the other one is the root. Which one's the root? Well, always remind yourself, roots are at the bottom. Roots of a tree are at the bottom. So the denominator is going to be your power of your root. Okay. Now, I showed you how to solve this in class one way. I'm going to do this a little bit different, and here's why. Because there's a little trick in here that you need to understand. Now, I need to undo this. I need to get x by itself. Okay, so the first thing that I want to do is get rid of that 3 that's in the denominator. So you have another exponent rule that says that when you have a power raised to another power, then you multiply your exponents together. Okay, so here's what I'm going to do. So we're going to start off with x to the 2/3 power equals 4. Okay, I need to raise both sides. I want to get rid of the 3 that's in the bottom. So whatever I do to one side, I'm going to have to do to the other. So if I were to multiply this by a 3, now look, 2/3 times 3, remember you can put it over 1. And do you see how the 3's are going to go away? To just leave you with your exponent. So I'm going to raise both sides to the power of the root. Okay? So the 3's are going to knock each other out to just leave you with x squared equals, well, 4 to the 3rd is 64. Okay? Now, here, this is the square root property. Okay? So that means this is going to give us x equals, and then don't forget your plus and minus 8. Okay? Now, you wouldn't have seen this coming, right? If we had not have broken it apart like this, you wouldn't have seen it coming, because what you can do in one step is raise both sides to the power of 3/2. And that would have killed this, raise this to the 3/2 power. Okay. But you would not have caught this thing about remembering that you needed to have that plus and minus there. So it's easier if you do this in steps. So let's do another example. So let's take x to the 2/5 power equals, let's see, 243. Okay. So the first thing that I'm going to do is I want to get rid of this. I need that to go away. So I'm going to raise both sides to the 5th. Oh, I didn't want to do that. Sorry. Let's change this number. Let's see. Hold on a second. Let me pause this and get a good number. Okay, let's go ahead and change that to a 4. We're going to use 4 again. So then we're going to raise both sides to the 5th power. Okay, so on the left side, the 5 and the 5 in the denominator are going to knock each other out to just leave you with x squared equals 4 to the 5th. So 4 to the 5th power is going to give you 1,024. Okay, now that's a big number, but we're going to take the square root of both sides. So now x equals, don't forget your plus and minus. Okay, now here's how you do this. If you want to know what this is, another way to rewrite the square root is to take this number and raise it to the 1/2 power. Okay, because remember, look at the exponent. See how the 2 is in the denominator? So that tells you it's a square root. And you get 32. Plus and minus 32. Okay? So that's how you deal with rational exponents. Okay. Now, I'm not going to give you an equation like that on the test to solve, so you can relax. Okay? But you are going to have some like that in your homework. Okay, now number 5, we have this equation. And we have x plus 1 raised to the 1/5 power equals -3. Well, here, I want to get rid of that 1/5 exponent. So the 1 is just an exponent. The 5th is the power of the root. So that means I'm going to raise both sides to the 5th power. So 1/5 times 5 is 1. So that goes away to just leave you with x plus 1. We're not taking the root of a number because we're raising both sides to an exponent. So this is -3 to the 5th power. Well, when you crunch this in, you need to put -3 in parentheses and then raise it to the 5th power. So we get -243. And then we solve for x. So we subtract 1 from both sides and get -244. And that is your answer. Okay. All right. Now, let's look at number 6. So we already solved something like number 6, which was a form. It turns into something like number 1. Okay. So when we isolate the radical for number 6, I have to get rid of that 3. So we have the square root of x minus 1 equals x minus 3. Okay, so I am going to square both sides. Okay, and so remember, this is going to be, to get your middle term, you need the 2ab. Okay, so on the left side, the square and the square root knock each other out to just leave you with x minus 1. So we have x squared. Now, 2 times a, so 2 times x times a -3 is a -6x. And then -3 quantity squared is a +9. All right. If you don't like doing that, then you expand it. X minus 3, get really fast at multiplying that out. Okay, so now we have a quadratic. So here's my x squared. I'm going to subtract x from both sides, so we get -7x. I add a 1 to both sides, so we get a +10. And we set that equal to 0. Well, there's only one way to get the x squared, and that's x and x. And what are two numbers that multiply to 10 that add to 7? Well, that would be a 2 and a 5. And how do I get a -7? They both have to be negative. So we get x equals 2 and x equals 5, but I have to check it. 2 minus 1 is 1. The square root of 1 is 1. 1 plus 3 is 4, not 2. So this does not work. Let's plug in the 5. 5 minus 1 is 4. The square root of 4 is 2. 2 plus 3 is 5. This one works. So we keep the 5. Okay. Now, number 7 is long because we have 2 of these radicals to deal with. So this is where we said, when you have 2 radicals, the first thing you want to do is make sure that one of them is isolated. And it is. The 1 minus 2x is isolated. So that means what I'm going to do is I'm going to square both sides. Now, I'm not going to do any shortcuts here. So the square of the square root is just going to leave us with 1 minus 2x. Now, on the right, this is the square of a binomial. So we have 2 of them. So that means we have to FOIL. So first times first, the first terms together, 2 times 2 is 4. Now, when we multiply the outer, this is 2 times this radical. So that's just 2 times the square root of 1 minus x. Well, the inside is 2 times this radical. So that's another 2 times the square root of 1 minus x. And then we have these 2 radicals that we're multiplying together. So that's just that radical that's being squared. The square root of 1 minus x times the square root of 1 minus x is that squared. Okay, so now let's clean up what we have. So I'm going to combine these two terms together. Okay, I'm going to go ahead and move that up front. So that's going to be 4 times the square root of 1 minus x. Okay, then we have the 4, this 4 that's out front, plus, now when I square this, that just leaves me with 1 minus x. Okay, so we're going to clean up what we've got. So we have a minus x plus 5. Okay, now I have a radical left over, so I have to isolate. So I got to move everything over. So let's move this minus x to the other side and that plus 5. So when I move the minus x to the other side, that's going to give me minus 2x plus x is a minus x. And then minus 5 on both sides. 1 minus 5 is minus 4. And then we're left with this 4 times the square root of 1 minus x. Okay, now I am supposed to isolate the radical, which means I've got to get rid of the 4. But if I do that, I have to divide both sides by 4. And do you see how I'm going to make it worse? It's going to become a fraction. So what you can actually do is leave it alone, but there's always a catch. You have to remember your exponent rule. So you have, and we've been going over some exponent rules. So one of your exponent rules is when you have a product raised to a power. A times b is a product. You're multiplying. I'm multiplying 4 and 1, the square root of 1 minus x. When you raise it to an exponent, then that just means that everything inside gets the outside exponent. Okay? So I'm telling you this because what we're going to have to do here is square both sides so that I can get rid of the square root. Okay, so once again, I have the square of a binomial. I'm not going to do any shortcuts. I'm going to expand it. Okay, now 4 squared is 16. And the square of this square root is just going to give you 1 minus x. So you're going to have to distribute that. But let's clean up the right side. So FOIL, first times first, minus 4 times minus 4 is a positive 16. Outer, minus 4 times a minus x is a plus 4x. Inner, minus x times minus 4 is a plus 4x. Last, minus x times minus x is a plus x squared. Then we distribute. Now we're going to clean this up. X squared minus 8x plus 16 equals the right side. So now we need to move everything together. So here's my x squared. I'm going to add 16x to both sides, which makes this a 24x. 16 plus 8 is 24. And notice what happens here. I subtract 16 from both sides, so they go away. So this is what we have left. Now, normally when we factor a trinomial, but this is a binomial. So I need to first look, do I have a GCF? And I do. I see that I have an x that's common. So I'm going to have an x plus 24 left over, set it equal to 0. And then remember, you set each of those factors equal to 0. Okay. Now, for purposes of time, you can plug this in and check, but I'm going to tell you that 0 does not work and x equals negative 24 is your solution. Okay. I would not dare put this on the test. Okay, because one tiny error and the whole thing falls apart. All right, but it's good practice for you to go through because it does sharpen your algebraic skills. All right. Okay, so let's look at these last two problems, number 8 and number 9. They're word problems. They're going to go by really quick. Okay, number 8. So it says Gabriel dropped his phone from the edge of a cliff. He heard it smash on the rocks 3 feet, the rocks below 3 seconds after he dropped the phone. Gabriel knows that the time t in seconds for a free falling object to fall d feet is given by this equation. How high is the cliff? Okay, the first thing I want to do is identify my variables. So t is referring to time in seconds. D is referring to the distance in feet. So I need to know, what did they give me? It said he heard it smashed on the rocks below 3 seconds after he dropped it. So that means they have given us time to be 3 seconds. So if they've given us time, then that means I'm going to solve for D. Okay, so how do we solve this equation? Just like we had before, our radical is isolated. So that means we're going to square both sides. So this gives us a 9. The square is going to release the square root. So we get D over 16. And then how do I solve for D? Well, it's being divided by 16. So that means I'm going to multiply both sides by the denominator. And we end up with D equals 144. D is distance measured in feet. So D is 144 feet. Okay. And that's number 8. That one was really, really easy. Okay. All right. Now let's look at the last one. So there are 3 parts to this. The first 2 are the same. The third one is a little different. So it says Keebler's law gives a relationship between an animal's metabolic rate, MR, and its body mass, M. MR is measured in kilocalories per day, and M is weight in kilograms. And you're going to need that because of how you have to leave your answer. So part A says, find the metabolic rate of a lab mouse weighing 0.02 kilograms, which is about twice the mass of a pencil. Find the metabolic rate. So I'm looking for MR, which means they gave me little m to be 0.02 raised to the 3/4 power. Okay, so I need to figure out what this is. Well, guys, I'm not going to sit there and find the 4th root of 0.02 and then raise it to the 3rd power. I'm just going to use my calculator because it says round to the nearest whole unit. So I'm going to crunch all this in. So 73.3, open your parentheses, 0.02, close it, raise it to the 3/4 power, and hit enter. Okay, so my metabolic rate is going to be approximately, because I have to round it to the nearest whole unit, that's going to be 4. Now, what is my unit? Well, they said that the metabolic rate is measured in kilocalories per day. So that's kilocalories per day, KC per day. Okay, and that's all you had to do. So it was plug the number in and then number crunch it. All right, B, find the metabolic rate of an African elephant weighing 3,000 kilograms, which is about one Ford Taurus. Round your answer to the nearest whole unit. Okay, so the lab mouse had the metabolic rate of a lab mouse. I'm sorry, I'm getting tongue-tied. We had to find the metabolic rate of this lab mouse that weighed 0.02 kilograms. the metabolic rate was 4 kilograms a day. Well, an elephant is this African elephant weighs 3,000 kilograms, which is a lot more than 0.2. So that means that your metabolic rate better be way higher than 4 kilocalories per day. So again, we're looking for the metabolic rate. So this is 73.3 times 3,000 raised to the 3/4 power. So the metabolic rate is approximately, well, we're going to do the same thing, 73.3 times 3,000 raised to the 3/4 power. And we're going to round this to the nearest whole unit. So this is going to be 29,713. And for metabolic rate, our unit is going to be kilocalories per day. And that is considerably more than the lab mouse that weighs 0.2 kilograms. Okay. All right. Now the last one. What is the mass of a house cat that has a metabolic rate of 245 kilocalories per day? So now we have to find the mass. They've given us the metabolic rate. So let me just rewrite our equation. So here's our equation. They've given us the metabolic rate of 245 kilocalories, and we have to find the mass. Now look, the lab mouse had a kilocalorie of 4 kilocalories a day. That African elephant had a metabolic rate of 29,000 kilocalories per day. And they're telling us that the metabolic rate of this house cat is 245. So you're in between here, which means that your mass better be in between 0.02 and 3,000. Okay. So now we have to solve for M. So this is not going to be as bad as you think. The first thing that I'm going to do is, well, I don't want to touch the M to the 3/4 power. Okay, that's the last thing I'm going to touch. So I need to get rid of the 73.3. So we're going to divide both sides by 73.3. Now, I already know enough, and let's go ahead and do this. 245 times 73.3. That's an ugly decimal, and we're not going to mess with that. We're going to leave it alone, leave it just as it is, okay? So we're going to take 245 divided by 73.3 equals M to the 3/4 power. Now, notice we have a rational exponent with an even root. So if we have an even root, then we have the possibility of having a negative answer. But if we're looking for mass and we end up with the negative answer, I don't want that negative answer. I only want the positive one because you can't have negative mass, right? So all we're going to do is, how do I get rid of the 4/3? That would mean that I raise this to the reciprocal of 4. I'm sorry. I have M to the 3/4. How do I get rid of the 3/4? I would raise it to the 4/3 power, but whatever I do to one side, I have to do it to the other. Okay, so now look, these guys are going to knock each other out. It says round your answer to the nearest unit. So that means I'm going to have an approximation here. Okay, so we're going to crunch this. So open your parentheses. 245 divided by 73.3, close your parentheses, raise it to the 4 divided by 3 power, and then round that answer to the nearest whole unit, which is going to give you 5. Now, we found M, which is mass. What is our unit for mass? What did they tell us? Mass is the weight in kilograms. So that means that this house cat has a mass of 5 kilograms. Okay. And that's all you had to do. All right. So that's it for section 4.6. All right. Let me know if you have any questions.